Hello everyone, this is teacher Justina and welcome back to my channel. And then for those who are still new, do not forget to subscribe, like, and share. And do not forget to hit the notification bell for more video updates. And you can also leave your comments below and suggest topics. And another thing, please do not forget to watch starting from the beginning of my video all throughout the end because I am giving examples starting from easier to difficult. Okay, so our video for today is all about solving quadratic equation by extracting the square root. Okay, so this time we will be going to find the solutions of quadratic equation or solving the roots of quadratic equation. Actually, there are four ways in finding the roots of a quadratic equation. We have A, extracting square roots. We will be getting the roots by extracting the square roots. Another one is factoring. Then the third one is by completing the square. We can get the roots of a quadratic equation by completing the square. And the last one is we will be getting the roots of a quadratic equation using the quadratic formula. Okay, so before anything else, let us have this question. How many roots does a quadratic equation has? So let us have a recap. Okay, an example is 2x plus 8 is equal to 4. And then we have already known that if we are going to get the value of an unknown, it should be placed on the left and then the constant should be on the right. So therefore this will be 2x is equal to the positive 8 will be transposed, then this will become negative 8. And then so far 2x is equal to negative 4. And then since the uh, x has a numerical coefficient of 2, and then since we will be getting the value of x, thus we are going to use the division property of equality. Then whatever the numerical coefficient beside the variable, then that will be our divisor to both left term and right term. So therefore, we will be dividing to both sides. Thus, we are getting the value of x this time as is equal to negative 2. And what is this negative 2? The negative 2 is said to be the root of the equation. But what kind of equation is 2x plus 8 is equal to 4? And we have only one root, which is negative 2. So again, what is 2x plus 8 is equal to 4? This is the so-called linear equation. And as I've said, that x is equal to negative 2. And is there any possibility that we can get other value of x other than negative 2? Okay, so far a linear equation has only one root. And what do you mean by linear equation? It is an equation with highest exponent of 1 in the variable. So as you have seen that 2x plus 8, the x is our variable and then it has an exponent of 1. Thus 2x plus 8 is equal to 4 is said to be a linear equation. And then how do we know if x is equal to negative 2 is really correct? Thus, we are going to do the checking. Checking means we will be copying the original equation, which is 2x plus 8 is equal to 4. And then we will be substituting the value of x, which is negative 2. So instead of 2x, we'll be writing 2 times negative 2. And then plus 8 is equal to 4. Thus, 2 times negative 2 is equal to negative 4 plus 8 is equal to 4. And then negative 4 plus 8 will gives us 4, which is equal to 4 on the right side. So therefore, if they found to be equal, thus our root, which is negative 2, is correct. Okay, so let us proceed. And then so far we are not yet done answering the question as to how many roots does a quadratic equation has. Okay, if a linear equation, so a linear equation is said to be an equation with highest exponent of 1 in the variable, has one root. Okay, given 2x to the power of 1 plus 8 is equal to 4, which is the root is only 1. So there is only one root, which is negative 2. So again, if a linear equation has one root, okay, and then if a cubic equation, so what do you mean by cubic equation? Okay, a cubic equation is said to be an equation with the highest exponent of 3 in the variable. So if a cubic equation has 3 roots, so like this, x cubed plus 2x squared minus x minus 2 equals 0, then there are 3 roots, the negative 1, negative 2, and positive 1. And then if a quartic equation has 4 roots, what do you mean by quartic equation? So it is an equation with highest exponent of 4 in the variable. So as you have seen, if a linear equation has one root, we have only one root in the given equation. If a cubic equation has 3 roots, of course, we have also 3 roots as we have in the given. And if a quartic equation has 4 roots, there will be also 4 uh, values of x that will possibly satisfy in this given equation. Okay? So, again, if linear has 1, if cubic has 3, and then if quartic has 4, then what about the quadratic equation? So a quadratic equation example there is x squared plus 11x plus 30 equals 0. So I think you have already seen the pattern. So a quadratic equation, as you have seen, the highest exponent of the variable x is 2. Then it is being said that every quadratic equation has 2 roots. So we have already answered the question, how many roots does a quadratic equation has? So a quadratic equation has 2 roots. So the given there is x squared plus 11x plus 30 equals 0, and thus the values of x are 6 and 5. So the roots are 6 and 5. The highest exponent of the variable is 2. Thus, there will be also 2 roots that will possibly satisfy to the given. Okay, so let us have this example. Solve the roots of this quadratic equation, which is x squared is equal to 36. Okay, what is step 1? Okay, step 1, we will be setting to it that the term with the variable with the power of 2 should be always on the left alone, and then the constant should be transposed to the right. And so far our given is already they are already on their places. So x squared should be on the left, and then is equal to 36, the constant term on the right. And then what is the next thing? This time we can no longer use the division property of equality. Why? Because it is the 2 there is not a numerical coefficient but an exponent. So how do we isolate the exponent 2 there as to get the value of x? So therefore, since this is a square, so therefore we will be isolating the 2 there as to have x alone. We will be getting the square root, or we will be extracting the square root. How do we extract the square root? So we will be extracting the square root both sides. So as you have seen, we are getting the square root of x squared, and we are getting the square root of 36, because as an equation, what you did on the left, do it on the right. And then next thing is, since we will be getting the square root of a constant, we will be setting to it that there are 2 possible square root of a positive radicand. What do we mean by radicand? It is a number inside the radical sign. So what are the 2 roots of a constant? There are 2 roots. The principal root, which is the positive, and the negative root. Therefore, we need to write there the double sign, the plus and minus. So what is the next step? Getting the square root of x squared is already x, because The square root is telling us that it has an index of 2. So there is an index of 2 in here. And then if the index is same thing with the exponent of the radicand, thus we are simply isolating the symbol. So it will now become x because the square root of x squared is x, which is equal to positive, negative, the square root of 36 is 6. So it is the positive 6 and the negative 6 because positive 6 squared will gives us positive 36. And then if we will square a negative 6, we can still obtain a positive 36. So therefore, the values of x are the positive 6 and the negative 6. So it could be written in this way. There are two roots. So is it true that a quadratic equation has two roots? Yes. So the quadratic equation x squared is equal to 36 has two roots which are positive 6 and the negative 6. And then how do we know if we are correct? We will be doing the checking. So the original equation will be copied and then 6 as our first root. So substituting it to the x, so 6 squared, positive 6 squared is equal to 36. Okay, so therefore, 6 squared is equal to 36. At the same time, negative 6 squared will also gives us positive 36. Let us have another example. Number 2, 5x squared minus 125 is equal to 0. Remember that in finding the roots of a quadratic equation, we have to see to it that we will be setting the left side and the right side to be a perfect square. So what will happen if they are not yet a perfect square? So we have to try see what is the numerical coefficient of our variable with an exponent of 2. So there is a 5 in there, but at the same time, we need to write it first in this way. The variable x squared should be on the left and then the constant should be on the right. Again, there is a 5 besides the x squared. Thus, we cannot proceed to extracting the square root. So uh, how do we isolate the 5 in there? So we need to divide both sides by that numerical coefficient beside the x squared. And then we need to divide both sides by 5. And then for that, the remaining expression will be x squared is equal to 25 because 125 divided by 5 equals 25. Next, we have to see that they are already both perfect square on the left and on the right side. So we cannot proceed extracting their square roots. So the square root of x squared is equal to the square root of 25. But do not forget that there should be a double sign. Okay, so because if we are going to get the roots of a quadratic equation using extracting square roots, we need not to forget the double sign. So therefore, the square root of x squared is x and the square root of 25 is already a positive and a negative 5. So therefore, our values or our two roots are 5 and negative 5. So for the checking, we have to copy the original equation 5x squared minus 125. Is it equal to 0 if we will be substituting the 5 and the negative 5? Okay, so far. So 5x squared, instead of writing x, we have to write it 5. So therefore, 5 squared is 25 times 5, it's 125. Minus itself, the result will be 0. What if we will be using x is equal to negative 5? So if it is negative 5, then 5 times the negative 5 will be raised to its power of 2, then it will become positive 25. Times 5, it will be 125 minus itself, it will be a 0. Okay, so let us proceed to example number 3. So given 36a squared minus 144 is equal to 0. Okay, as you have seen, they are all both perfect square, but we need to transpose the negative 144 to the right. And since they are already a perfect square, thus we need to extract them to their square roots. A double sign in there, and the square root of 36 is 6. The square root of a squared is a, while the square root of 144 is 12, and then the double sign. And we are not yet done getting the value of a, so we need to divide both sides by 6. Okay, so far the value of our a is 12 divided by 6 is 2. So the two roots of that expression 36a squared minus 144 equals 0 are 2 and negative 2. So these are the two roots. Checking using the positive 2. So therefore 36 times 2 squared minus 144, they are equal. And using the negative 2, same thing. The left, which is, the 36 times 4 minus 144, therefore they are equal. Okay, let's proceed number 4. Last time, number 4 is involving a fraction. It is still the same process. We need not to worry as long as we will be applying the concept, the process, and so on. So therefore, we need to try see if they are already a perfect square. Yes, is a 1/4 a perfect square? Yes, as well as the x squared. And then the 4 over 36, the 4 is a perfect square while 36 is also a perfect square. So, the next step, we need to extract the square root both sides. So, we are done extracting them. And then, we have the double sign. And what is the square root of 1/4? The square root of 1/4 is 1/2. The square root of x squared is x. Well, the square root of 4 over 36 is 2 over 6. And so far, we are not yet done because x has a 1/2 as a numerical coefficient. So to isolate the 2 there as the denominator of x, because 1/2 x, same thing with x over 2. So to isolate the 2 there, we need to multiply a 2 to both sides. Why we are using a 2? Because the 1/2 has a denominator of 2, and then we need to isolate the 2 there in order for us to obtain the x. So therefore, what is 2 times 1/2 x? So this will already gives us an x, because 2 divided by 2 will gives us 1x or x. And so far, 2 times 2 will be 4. And what is 4 over 6? So 4 over 6 is just the same thing as 2/3. So what are the two roots? The two roots are 2/3 and negative 2/3. So these are the two roots of the given quadratic equation. So how to check them? So far in the checking, we'll be using the original equation. We have 1/4 x squared equals 4 over 36. And so far, let us try the 2/3. So 1/4 x squared equals 4 over 36, in which the x is 2/3. So that's it, 1/4 times 2/3, which is our x to the power of 2. Is it equal to 4 over 36? Okay, remember we cannot multiply the 2 and 1 directly because we need to apply the GEMDAS or the PEMDAS. So therefore, 2 times 2 will gives us, squaring a 2, we have a 4, and then squaring a 3, we have 9. So therefore, that will be 4 over 9. So are they equal? What is 1/4 times 4 over 9? So 1 times 4 is 4, and 4 times 9 is 36. So 4 over 36. So they are equal. Same thing with the negative 2/3. So remember that if a negative number raised to an even exponents, the answer will gives us a positive always. So therefore, 4 over 36 is equal to 4 over 36. Guys, I hope you've learned something from my video, and I hope you keep on watching for my coming videos, because there are still three ways in finding the roots of a quadratic equation. So I hope you will leave your comments there, and then you can suggest any topics. This has been Teacher Justina, and thank you for watching.